is fine since yesterday. So let me start by just asking you if you have any question or if you want to answer any of our questions. Would you just please raise your hand? I think you all know we have this option to raise your hand using Zoom just to coordinate how we'll speak instead of speaking all together. And of course, if you have any question, don't hesitate to write it in the chat or raise your hand and then speak it through the microphone. Okay, Mohammed, go ahead.
Yeah, hi Rasha, how are you? Good.
Hi, Mohammed.
I have a of course, question. There is a book called Micro-econometrics using data. It's by Data Corporation. Do you suggest following up with this, or it's useful or not?
Yes, it's very useful book. In fact, there are 3 useful books for what we did. I mean, what we are doing in this training. So, micro-econometric using this data is very useful one. You have also another book called Mostly Harmless Econometrics. It's kind of old book, but it includes a lot of applications and examples, mainly on the US economy, but still is very useful and explains the theory and then shows you some results using data or other softwares. And of course, you have Woodbridge book, panel data and time series. So yeah, I highly recommend these 3 books.
Okay, thank you.
My pleasure. Any other question, comment, feedback before starting? Okay, so let's start by your. Okay, we'll go over the PSM again, and this will be through your assignments. So we have, I will start sharing my screen. We have this list from yesterday. Okay, just to show you. So if you remember yesterday, we start estimating the PSM and the 3 steps theoretically that are produced automatically by Stata, by the command PS match 2, is that you have to estimate the logit or probit model using all the X's or explanatory variables that you think it would affect the likelihood of being member of this program or of this treatment. Then you will use this propensity score to match between the treated individuals and the non-treated individuals, and how you match, you have different methods using ties with the closest observation or with the average of the closest n observations, or using kernel function with the different types. And then after matching the individual based on the common support, the individuals who have a counterpart in the counterfactual group, you can estimate the average treatment of treated by comparing the outcome between these 2 groups. And we saw yesterday that one way to be sure that your match is correct, that you compare the average value of the variables you include in your logit model between the 2 groups. If there is significant difference between the 2 groups, this means that your match is not good and you have to find new variables or do new other methods of matching. And if you don't have significant difference between the values of these X's between the 2 groups, this means that you are doing a good match, because we assume that we want to match every beneficiary with non-beneficiary based on these observable characteristics that we think it would affect the participation in the program. The other thing also I repeated several times yesterday, that we have to make sensitivity analysis by using different methodology methods and be sure, different matching methods, and be sure that these methods are not affecting our results. So now I would like to ask a volunteer from each room to share their screen with us and show the results of their output. If there is no volunteer, I will choose randomly. So who would like to start? Okay, Fatma, would you like to start? Okay, and Josephine. So let me see. So Josephine, you are from room 1. Fatma, would you like to do it for room 3? Okay, so let's start by Josephine and give you time to think. So for room 1, you were asked to rerun or to do the PSM methods using the average. So the matching method to use is to use the average between the 5 closest observations. And what we want to see if this provide us with the same conclusion or the same results concerning our program, or in our case was having someone migrant and receiving remittance on female labor force participation or not. So Josephine, you can start by sharing your screen and speak.
Okay, hello. So do you see my screen and can you hear me good? So I'm just making sure if you can hear me.
Yes, we can hear you.
I will show you the output, but I would like also to make sure I understand the model. Like, if you don't mind, I have some questions.
Yes,
okay?
sure. Go ahead.
Thank you. So first, I noticed that in the do file, you have put this this line where we had the kernel option.
Mm-hmm.
So in case for room 1, I replaced it with N5. And so here's the output. So first, I noticed that in your case, by in your case, I mean this. So here, when you showed us what should we see, you mentioned that we have to see a logit regression output. So it seems mine took a probit. So this is the first question. What does determine whether Stata would conduct a probit or a logit regression?
I think probit is the default one, and there is an option to change or to define which regression use.
Okay.
But it should provide you the same. I mean, it will not really change the main results or the main conclusion.
Mm-hmm. So here we have to look here at the significance. And so basically, whenever the factors are not significant, this is good, because we would say there's no significant difference between the treated and the untreated. So please correct me whenever I'm wrong.
Yes, so no, so I have to correct you here. So no, in the probit or logit regression, which is your first step, it's not a good sign if you don't have significant variables. Because in this first step, you are trying to explain the likelihood of being part of this program or part of this treatment. So if you're, I mean, here is an example that I'm giving you, so it's okay if it's not really, not all the variables are significant. But if you are doing your analysis, you need to be sure that you are including, I mean, as if you are doing any logic regression, you need your variables to explain the likelihood of being in this status. Okay. Because if it's not the case, this means that you are not really explaining, or you are not able to explain the likelihood of being beneficiary of Bolsa Familia or of Takaful or of any other program. Okay, so what I told you, it's good if it's not significant, is a step that we can do later by comparing the mean of these values of these variables between the two groups, the match, the beneficiary and the non-beneficiary. But at this stage, I'm trying just to explain what are the variables that would affect my likelihood to be participant in this program or not.
I see. Okay, thank you.
Okay, yeah.
Okay, then the next step is this one, where we have the average treatment effect on the treated. So here also, to make sure I understand the whole concept, here we are looking at the average like migration effect on those migrants. That's it?
Yeah, so here they are comparing, I mean, this WOM LFP is the women labor force participation. This is your variable of interest. Okay. And it's giving you its average value between the treated and the controls. So after this first step is conducted, after doing the logic, you remember in our in the presentation yesterday, we said we have to estimate P hat, which is the estimated propensity score. Then based on this P hat, you make the matching, which in your case is N5 is the average of the 5 closest neighbors or 5 closest observation. So between the first table and the second table, Stata did all this, estimate the propensity score, do the matching, and then compare the labor force participation between those who are treated and those who are not treated. And provide you with this second table, which is in 2 lines, where it gives you the value of the treated and the control. No, can you just stay like this in the screen? So in this, yes.
Here?
Yes, exactly. In this table, Stata told you that now, after matching the observations, the beneficiary and non-beneficiary based on the propensity score, your variable of interest, which is the labor force participation, its value among the treated is this, and its value among the controls is 0.32, and then the difference is 0.07, and it provides you the standard error and the t-statistic to conclude if it's significant or not significant.
Okay.
Okay. So from this table, like yesterday, we can conclude if it's significant or not the fact of receiving remittance, being in a group of receiving remittance compared to group who are not receiving remittance on labor force participation. So there is significant difference?
Yes.
Yes, there is significant difference. So the same results as what we found yesterday.
Right.
And then in your third table, it shows you how many observations are treated and how many are not treated who exist on the common support, who had the same values of the p-score. Any other questions?
No, basically that's it. Thank you for the clarifications.
Thank you, Rosine, for sharing your results. So, Mohammed, yes, go ahead.
Yeah, so I saw that regarding the R-squared, it is not our case here, or what? Because
usually R-square in the logic is very low. In general, it's lower than other models. But here again, it's just an example for simplification. But you need, in the logic stage, you have to work on it as if it's any model that you want to have higher explanation, higher fitness of the model, and a higher explanation power, and you have your variable significance. But just for your information, that logic model usually it has lower R-square. Shahir, you would like to say something?
Yes,
exactly.
Perhaps I just want to also add to these points on Rasha's comment to Muhammad. Generally speaking, in most of the models where we use individual data like firm level data or household data or individual data at the individual level, not the household level, the R-squared is in general very low. And in general econometrics, what matters more than the R-squared, it's one of the indicators that we have a goodness of fit of the model, but generally speaking, what matters more, 3 things. So first, that the model is correctly identified, so you don't have any omitted variables or any endogenous variables, because these 2 problems, they affect a lot the biasness of your results. Second is the significance of your variables align with the literature and with the economic theory. And finally, to what extent, significance is a statistical story, but also what matters is that your results make sense from an economic perspective. So those are the 3 criteria based on which you can make sure that your model is correct or not. So first, that it's well identified. Second, that the variables are statistically significant and with the correct sign. And third, the results are in line with the economic theory. And if they are not in line with the economic theory, how can you justify that they are not aligned to this? So, these 3 indicators are much more important than the R-squared itself.
Yeah, exactly.
And as I said, it's just first step of the PSM method, but you have to work on it as if you are interested in the results of this model by itself, because it would allow you to explain the likelihood of being part of this program or not.
Yeah.
Okay.
And I am in room 1. I did something extra, that I tabulated the matched nearest neighbors, the NN.
No, I didn't get what you did exactly.
I will share my screen.
Okay, go on. Yes, Zena?
After Muhammad, if you want, I just want to ask, I understand that there are different ways, like neighbor and then kernel and all of those, but like, how do you make those decisions, and why did you decide on 5? Like, why not 6, 9, not 7?
Yeah, exactly. There is no specific criteria that would allow you to decide. And for this, for this, we need to do the sensitive analysis and you tried. I mean, like the caliper, for instance, the caliper I suggest is 0.01, but it can be 0.02. So, of course, if you use the mean of the 7 closest neighbors will not be the same as the mean of the 3 closest neighbors. So, I mean, 5 is not very large number and it's not very small numbers, but you have to try different matching method, and within each method you have to try different parameters like the bandwidth for the kernel function and the number of neighbors observation in the average number of observations, just to be sure that you are not really doing, that your results are not related to the selection of the number, which has no specific criteria how you can select it.
Okay.
Can I ask
Yes,
you a question?
Yes.
Okay, so I tabulated the matched neighbors, nearest neighbors, and I have this table here, but I don't know what does it mean exactly.
Okay, I
Because
think
to have 0 and here 5.
Okay, I think, I'm really not sure about it because I never did this, but I think this means 0 are those who were not selected in the 5 neighbors, and 5 will be the fifth neighbor, or the 5 neighbors that are selected, and it just shows you the distribution, but I really don't know what does it mean. Can you show the data?
Yeah.
I mean, you can just edit p-score.
Because when we did the N5, we have now 5 nearest neighbors.
Yes, so as this variable shows you the number of matched neighbors. So or is 0,
and the last one is the matched neighbors. It's a variable called matched neighbors. Is it showing on the screen or not?
No, we can see it.
Oh. I think here it is. Yeah.
So I'm not really sure what does it represent, but I think you see in your variables you have N1, N2, N3, N4, exactly. N5. I think this is for each observation. They told you the score of the first neighbor, the score of the second neighbor, the score of the third, of the fourth, and the fifth, because they are doing the match based on the average p-score of these 5. So, for instance, if Russia, I am the treated individual, and my 5 neighbors who are closest to me is Shahir, Muhammad, Josephine, Zena, and Mus'ab. So they show you like this N1 to N5 created variables. I think I'm not sure, but I will double check. From N1 to N5, it shows you the score. So you have Russia, my p-score, and then you have N1, the score of the first neighbor, Shahir, then the score of Muhammad, then the score of Zena, of Josephine. So it shows you the score of the 5 neighbors.
Nearest, yeah.
Yes, the 5 nearest. And then the average of this one, I think it may be created by the N1.
Yeah, it's called the matched neighbors.
Yeah, so I think this is like, it shows you who are the neighbors, or what are the value of the scores of the neighbors, and that for each treated value, and then the average based on which they are matched.
Yeah, and if we added a caliper, I think it will be another case, right?
Yes, calibrate limit. So as I was just saying to Zena, because I mean the 5 closest neighbors, it depends. It can be very close or very far. I mean the difference between me and the 5th neighbor observation, it could be 0.01, and it could be 0.0002, for instance. So the caliper allow you to make a maximum distance that you should select an observation within this maximum distance, not lower, not higher than this distance. And this may restrict more your,
exactly,
matching. Yes, make it more difficult.
Okay, thank you.
Okay. Thank you, Mohammed. Okay, for room 2, just for gender balance, Musab, would you like to present your, to show your output? Zena, you have other question, or this is from?
Sorry, this was the old one. I'll
Okay.
remove it.
Josephine, you'll be presenting room 3, but just go by order.
Oh, sorry.
Or if you have question, you can ask.
No, I just presented room 1. I just presented room 1. But the reason I raised my hand is because for the N5 in my output, I had the same results as Muhammad was showing right now. So I don't know if this helps explain what's happening. So here, in his case, for the untreated, he has 0, and then for the treated, we've seen 5. Right, but I could see the same exact numbers. So
yes, so I think he has this. What Muhammad shows us, the 5. It means those who had been matched with the 5 closest neighbors.
Okay.
Who are
yes.
the treated.
Yes.
And 0 are those who had not been matched with anyone. So those are the untreated.
Mm. Yes. So
Okay.
that's just wanted to share this.
Okay. Thank you. Thank you, Josephine. So room 2, Musab, would you like to present? To share your screen? Okay, if not, if is anyone in room 2, Musab, Ola, Sukaina, Heba, is anyone interested in sharing their screen and discussing together? Okay, thank you, Musab. Musab, you are muted. Musab? Musab, would you please just show the table of results and to discuss it? Musab? Yes, would you stop here? Musab? So you can see from the results of Musab that for the probit model, you should not have any difference whatever the matching method you are using, because you are not changing anything. You are introducing the same variables, and you say you are trying to explain the same y variable. No, Musab is not muted, but I don't know why we can't hear him. So this was a probit output should be the same. Here you can see that Musab did the analysis for the 4 variables of entries that we were talking about: labor force participation, wage salary, non-wage work salary, non-work salary, and subsistence work. And so for the second table, you have these 4 indicators, and you can see from the T statistics that there is significant difference between labor force participation, wage, work salary, non-work salary, and subsistence between those who receive remittance and those who don't receive remittance. Musab, would you please go to the Yes, please. So we have the same things, the same treated and untreated. This does not change. And then can you go further, please? Because I see that you make the comparison between the two groups, the variables of the two groups. Yes, so this is what I was talking about. We need to have non-significant difference between the values of the treated and the control groups for the different variables. So by PS test and including all the variables you are including in your analysis, Theta calculate or run the t-test to compare significance between the two groups. If you have any significant difference between the two groups for any variable, this means that there is a problem in the matching, and you have to use another matching method or use other variables. Maybe these are not the best variables to explain your treatment or your group. Thank you, Musab. I think Fatma would like to do room 3. You can stop sharing your screen, Musab. Thank you.
I just want to make sure that everyone hears me, right? Hi, do you hear me?
Yes, we can hear you.
Thank you. So for the step, I supposed to do the kernel uniform type. Okay. I just have one question here. For room 2, we were supposed to run the model with the kernel, but the type was normal. Does it make any difference if I just typed kernel or just kernel then normal, like I do with the uniform step, or kernel itself, it means normal?
No, I didn't get your question. Would you say it again, please, Fatma?
Okay, so for the kernel method, should I identify that I specify the normal type, or like I'm doing here with the uniform, I mean, or I just, the fact that I just typed kernel, it means it will use the normal type?
The default one is a normal type. If you want to change, you have to use the option between brackets and write a different function.
Okay, great. So it happened to me that the default is a probit regression as well. There is some significant relationship with some variables, like
number of children below 5 years old.
Exactly. And
the village characteristics at the end, share of male who is working in private sector and working in agriculture, and the unemployed.
Yes. Also, I have a question here. If I try different matching methods and I have like different significant relationships between different variables and the variable of interest, does it make any conflict if I have different significance between different variables and the variable of interest, or I should have the same significance relationship between the same variables if I try different matching methods?
You should have the same for the first table, the probit regression or the logic regression. You should have the same results, whatever matching method you are doing, because this step is the first step and it has nothing to do with what matching methodology you are using. So, for instance, if age was significant when you use kernel uniform, and when you change for the n neighbors observations and it become not significant, this means there's something wrong. Because this first step has nothing to do with what type of matching you are using.
Then for the second step, the average treatment, there is a difference. So it means I have the same results as the first and second step. And also there is no change in the number of untreated and treated. And I did the BS test, and yes, I have to do that to check after each and every matching method to make sure that there is a difference. Okay, okay.
And,
I have
yes, go ahead.
I have one question that I didn't really understand. Actually, there are two. The first one, when we are identifying the distance of the caliper, for example, when we had the first step that we were supposed to assign 5 for a number of neighbors, but for calipers we didn't have exact distance. Does it mean that I'm allowed to try different distance, and then I run the sensitivity analysis to check which one is the correct distance? Or I found on the internet that the default distance is 0.2.
Yes, exactly. So you can do, use caliper if you want to change the default distance, if you want to extend it, for instance, if there is no close observation with 0.02 distance, so maybe you need to extend it to 0.05 or 0.04, okay. And caliper, you can use it when you are using the average of n observations, or even if you are using with the one-to-one match. Remember, there is one-to-one match that will only with the closest observation. And here I can define maximum distance using caliper, or I can use 5 or 4 or 6 average observations, and here also use caliper. And do like correct one. Again, it's kind of sensitive analysis. I mean, you try to change a little bit and see if you have significant change in your results or not.
Okay.
Okay.
Great.
And if just last comment, if everything is correctly specified and your model is correct and everything is correct, you should not have different conclusion. I mean, as you see, what I did yesterday and what the first 3 rooms did, we all conclude that labor force participation is higher among those who receive remittance compared with those who don't receive remittance.
Yes.
So this means that we are doing good. If we have different conclusion, for instance, for one matching method, you find that there is significant difference, and for the other one, there is no significant difference, or it's the opposite direction. Here it means that there is something wrong, and you have to double check what is the problem.
Okay. My last question is regarding the beta. It said here that if beta is larger than 25%, it means it's outside, or it's outside this interval. What does it mean? And I mean, what does this?
It's another test. It's R-squared test. Also to test the significance difference between the two groups, the matching group and the treated group. Sorry, the treated group and the non-treated groups.
Okay, so if it's larger than 25%, should I worry about something, or it's just
no, it's just the same thing. It's not significant, or it's significant or not significant. Here it would be significant.
Okay, great. And I'm sorry, but one last question: that whenever I interpret the results of the matching methods, I should always indicate that on average there is association or relationship between, for example, receiving remittances and women labor force participation, right? Yeah, and I should indicate always that these results are on average.
I'm not sure I understand the question. No, but so when you, I mean, if you go up the interpretation of table 2, the second table is that the average treatment on treated is significant and positive, which means that, I mean, yes, on average, women who receive remittance have higher labor force participation compared to those who don't receive remittance. Yeah, you have to say it on average, because it's average treated on treatment. You already are calculating an average indicator. Okay. This was the question, no?
Yes. Okay, I'm finished. Thank you.
And also on average, the variables in group treated are not significantly different from group control, the control group.
Yes, okay. Thank you.
Thank you. For the last room, so we have Lamir, Zeki, Nada, who would like to present, to share their screen. If you don't want to present and don't have any question, we can move directly to the difference in difference.
Can I say what I understand to check if it's right? Our matching kernel nearest neighbor doesn't relate it with different statistical difference between control and treatment group.
No, would you please repeat it again? I didn't understand.
does our matching type kernel or nearest neighbor or propensity score affect our difference between control and treatment group?
In fact, it's the opposite. So the difference between the control and the treated, I mean, the average values of the variables in the control group and in the treated groups would affect your way of matching it. I mean, if already there is the significant difference, so when you match, there will be a problem. But if you are sure that they have the same characteristics, then you should not cause any problem for the matching method, whatever method you are using.
Okay, thank you.
Zena?
Hi.
Hi.
I have a small question related to the fact that I tend to see a variable like command called p-score. And I'm going to share my screen 1 second. So apparently like you so I've been running the pmatch2, but also I found that some have used the p-score command.
Yes.
Do you not recommend it? And then my question would be, because then you would need to do and the other one, but then if I run the p-score command, I'm getting that the balance is not satisfied. So do you prefer to use the p-match2, ps-match2 instead of the p-score?
In fact, I don't have preference. I mean, I just use more examples on ps-match2, but you can use both. If you don't get the same results, you have to check what is wrong or what is p-score requires more.
Yeah, I'm trying to figure out what's the issue. I will figure it out. It's just that because it's giving me like the balance property is not satisfied. I will look at it more in details, but
Okay.
there's no bug in the PS score, so it's fine. Like people have used both. Okay.
We can discuss this more.
This is my question.
Yeah, I personally use more ps-match2, but I mean both are supposed to give you the same results, but maybe some in the function itself.
I will check it.
I will check as well, and we can discuss it together later.
Okay, thank you so much.
My pleasure, Hina, thank you. So if you have no more questions, so we can move now for the second method to solve the issue of non-randomization that Shahid discussed yesterday. Zena, would you please stop sharing your screen?
Yeah, I'm trying. Sorry.
No, it's okay.
Yeah.
Okay, let me share mine now. So thank you all for the effort of running the regression and trying to find what are the difference. So today, as I said, it is another method where we are trying to solve the issue of non-randomization, and we use the difference in difference. So the main identification assumption of this method, in the PSM, we assumed that the matching is, or the fact that an individual benefit from a given program is based on observable characteristics, or the variables, the x's we include in our analysis probit or logic model. But in fact, this treatment or placement into a given program, it can be based on observable and non-observable outcome. So for instance, if I get benefit from takaful, or if I am a beneficiary from takaful, it can be explained by my characteristics, observed characteristics, that my age, the fact that I am a woman, number of children I have, where I live, my income. But also it may be related to any unobservable characteristic related to, I don't know, place of birth, or the fact that I am a woman, or any other things that we cannot really capture by an observed variable. So if we assume that the selection is based, or the treatment is based on only observable, this is called conditional exogenality of treatment. And this is a very strong assumption that it's not always the case. But in fact, what happens that we can have unobservable characteristics that affect the selection in the program. And this unobservable characteristic, we can divide it into two groups. Groups that can change over time, and groups that cannot change over time. So, for instance, my place of birth would not change with time. I was born in Cairo. I will be born in Cairo till my death. It will not change. I'm a woman. This is supposed not to change over time. But other unobservable characteristics, I mean, I don't know, I have high IQ, this is supposed not to change with time. But maybe other unobservable characteristics, it can be changed with time. Maybe there is specific skill I didn't have, and now I have it, but this is unobserved and this change with time. So because we don't have this conditional exogeneity of treatment, because we assume that we have unobservable characteristics, we try to solve this by assuming that we'll consider or we'll take into consideration the unobservable characteristics that we cannot observe, but those that are not changing over time. Okay, so again, on the PSM method, we assume that the selection is only based on observable characteristics. Now we want to include the unobservable characteristics, but we only include those that are not varying with time to be able to consider. Okay. So the methodology of difference in difference allow us to exploit or get benefit of these two types of characteristics, the observed one and the non-observed one that does not change with time. Here, if you notice, I wrote exploits time or cohort dimension because I will show you that we can use difference in difference not only in 2 points of time, but also in 2 cohorts or 2 villages or 2 governorates. This can be done as well. Using difference in difference allow us to consider the unobservable time in varying, but still we will have the problem of the unobserved time varying characteristics. This already exists. The difference in difference is based on important assumption called the parallel trends assumption. This parallel trend assumption assumes that the outcome in the treatment group and the outcome in the control group will follow the same trend over time if there is no treatment, if there is no any problem. So let me show you something. In fact, I will try something with you. Okay, so assume that our outcome of interest is Y, the expenditure on food in the household, okay? And here we have time. And we have 2 points in time, one before 2015, before the implementation of the TAKAFL program, and the other one is after 2015, which is after the implementation of the TAKAFL program. So in point B, there were 2 groups of households. I will assume one is here and one is here. So you can see this from these 2 groups, that group, I will call it 1. Group 1 have higher food expenditure or vegetable expenditure compared to group 2. So at point B, without TAKAFL, without anything, the households who are in group 1 have higher vegetable expenditure compared to group 2. If there is no TAKAFL, over time, I mean, if we assume that income increased and I don't know, interest on nutrition increased, we can assume that the consumption of vegetables and fruits of group 2 will increase over time, and also the consumption and of food and of vegetables and fruit of group 1 would increase, and it will be parallel. Okay, so this is a parallel assumption. Without the treatment effect, if point 1 and point 2 there was a given difference between them, this will continue over time. The idea that when we implement the TAKAFL or when we implement any policy program, the higher group or the group of treated, if group 1 is the group of women who will get benefit of TAKAFL, we suppose that their consumption will increase in a different way and it will not be any more parallel. So this group 2 is the control group, okay? And this line is the counterfactual, the estimated one, and this one is the treated one. Okay, so we can see that this parallel assumption assumes that without any intervention, the increase or decrease, it depends, it will be the parallel between the 2 groups, the controlled one and the treated ones. So here we can see this difference. As I told you, this is the counterfactual is supposed to happen without that treatment, and the difference between both the treatment group real progress in or real increase in the vegetable and the fruit consumption and the counterfactual, this is the treatment effect. The problem that if this assumption is not verified or if we are not sure of this is violated, we will have a bias in our estimation. So we need to be sure that without the treatment effect, without the implementation of the program, this parallel trend is assumed and is verified. If it's not the case, we will have this the estimated counterfactual, while for instance, we assume that between the treated group and the control group, the increase will be monitoring the same level, the same difference. But for any reason, without the implementation of takaful, the individuals who are living in household in group 1 decide to increase more their food and fruits consumption because they are more concerned about the nutrition of their children, or because they change their job and they have higher income. For any reason, the counterfactual is not the estimated, the dashed blue one, it is the red one. So if this parallel between both are not verified, we'll have a bias in our estimation. We'll overestimate the impact of our program or policy. Okay. Yes, we can verify the assumption through data, through comparing between the 2 points, the trend of both if this program was not implemented. Okay. So under this condition of the strong condition of exogenality of treatment, we can just compare between the 2 groups. But as I said, this is not the case, and this is why we use what we call a first difference approach. Okay, what is this first difference approach? So we assume that we'll take into consideration the observable who are not varying over time, and also who can vary over time, and the unobserved who cannot vary over time. And we wanted to compare between 2 groups who are group is treated and not treated at point of time 0 before the implementation of the program and after the implementation of the program. Okay, so the time variation, or the fact that we compare over time, allow us to take into consideration any unobservable characteristics that we cannot include in our regression with the x's, but that does not change over time. If it changes over time, even difference will not difference in difference will not really consider this or adjust this. So this is what we call difference in difference. So the difference, so again, the difference approach, this is verified if we have the conditional exogenality of treatment verified, and this means that you will only compare the outcome of your treatment group and your control group at one point of time, taking into consideration all the x's you consider. But this is not the case. For this, we have to compute the difference between the controlled and the treated at a given point of time after the implementation of the program, and the difference in outcome between both before the implementation of the program, and make the difference between these 2 differences. And this was the D approach. So let's see mathematically how we can write it. So is the expected value of the outcome y of the treated group at point of time 1. Point of time 1 is a point after the implementation of the program, minus the outcome y of the treated individuals at point of time 0, which is the point before the implementation of the program, given x, which are the observed variables that we can control for among the at the period 1, minus the expected value of the control, the outcome of the control group at period 1, minus the outcome of the control group at period 0, given that the individuals are not treated in period 1. So T1 is the fact that the individual is treated at period 1. Okay, so if T1 equal 1, this means that this individual benefits from takaful program after 2015, and if T1 equals 0, this means that they are not benefiting of takaful after 2015. And before 2015, both are supposed to have no treatment of the program. Okay, so the counterfactual expectations are not expected to change over time. I mean, this second term of our equation is supposed to be, if it's supposed to not to change over time, it will be equal to 0. And in this case, the difference in difference will only equal to the difference between the outcome of the individual before and the outcome of the individual after. However, this equality to 0 may not be the case. Again, we can assume that both will, their consumption of fruit and vegetables of both types of individuals will increase, but maybe for the treated, it will increase more. So this is not always the case that it is verified. But if it's verified, in this case, the difference in difference would be simply the before and after estimator, which is the difference in outcome of the consumption of fruits of the household beneficiary from Takaful after 2015 minus their consumption of fruits before 2015. Is it clear till now? Okay, if you have any question or anything, please just, okay. Thank you, Josephine. Yeah, so as I told you, this is unlikely to hold in practice, okay? So the estimator, DD regressor, these are the steps. We regress the outcome of interest, our Y, YIT, will regress it. For instance, in our example is consumption of food and fruits and vegetables on 2 variables. The first variable is actually on 3 variables. The first one is the treatment status. If TI1 is a fact of being treated at period 1 after 2015 in Takaful example, and in all cases TI0 before 2015 will be 0. Before 2015 there was no Takaful program and no one was benefiting from Takaful. We'll also include a time dummy. This time dummy will equal 0 before the implementation of the program. So in our case, before 2015, and 1 after the implementation of the program after 2015. So we can write our regression as YIT equal alpha, constant term, plus beta multiplied by the interaction between the treatment status and the dummy time dummy variable, plus I don't know how to pronounce this, gamma TIT plus delta T. So we include the treatment dummy variable, we include the time dummy variable, and we include the interaction between both. Bear in mind that here, gamma, thank you. Bear in mind that here we don't have any covariates. Here is the simple version. We are not really including any other x's that would affect the regression. Okay, the YIT. We don't include the socio-demographic characteristics, but we can include it, and I will show you when we start to use them. Okay, so let's do this exercise together. So we have So we have sorry. YIT equal alpha plus beta, the interaction between both, I will call it D, plus gamma, the treatment effect, plus delta, the time effect. Okay, it was gamma, is correct? Yes. Okay, now I would like you to tell me what is the expected value of YI, okay, the outcome or the consumption of fruits for an individual when at period T equal 0. Okay, so before the 2015 equals what? Anyone can suggest?
Beta times D plus delta times T.
Okay, so pay attention. D equal Ti multiplied by T. So D is the interaction between the time variable dummy and the treatment dummy, okay? And the treatment dummy at period 0 is 0. Before 2015, when T was equal to 0, there was no treatment, there was no takaful. So again, what would be the expected value of an individual in period 0 if he was not treated after or she is not treated after. Let me show it to you again. I already. So the outcome of the expected outcome or the expected fruit consumption of an individual I in the period T, if the person is not treated at the period 1. So if we look at the equation, it will be alpha. So it will be alpha, the same thing, plus beta multiplied by T capital I1 equals 1 if the individual is treated at period 1, equals 0 if the person is not treated at period 1. So in our case, it will be equals to 0 because we assume here that the individual is not treated. And T, small t, is equal to 0 because this is our assumption. Plus gamma multiplied by 0 because the individual is not treated, plus delta multiplied by 0 because we are in period 0. So all this equal to delta. So again, the expected value of the outcome in case of at period 0 before 2015 for someone who is not benefiting from takaful after 2015 will simply equal to the constant term of our regression, alpha. If we would like to see the expected outcome of this individual I after the implementation of the program, okay, so at period 1, post 2015, taking into consideration that this individual does not really benefit from the program, so in this case we'll have what? Any suggestion? So again, the expected value of YIT, given that T capital I1 equals 0 because the person is not treated, and T small equal 1 because we are in the period post the implementation of the program, would be alpha plus beta 1 multiplied by 0, so it will be 0, plus gamma multiplied by 0 because the person is not treated, so it will be 0, plus alpha multiplied by 1.
Alpha plus delta, small delta.
Alpha plus delta. Okay. Okay. No, it will, yes, exactly. It will be alpha plus delta. Alpha is our constant term. So it will be alpha because it's the constant, and delta is the coefficient of the time effect, and because we are in period post 2015, so it will be T equal 1, so it will be alpha plus delta, okay? So if we wanted to see the difference between I am an individual who is not benefiting from takaful, the difference between my consumption of fruit and vegetables after 2015 and my consumption of fruit and vegetables before 2015 will be simply what? Delta, exactly. It will be the difference between these two equations, and it will be delta. Okay. Now let's see the outcome of the individual I before the implementation of the program at T0, taking into consideration that she is treated and she is beneficiary from takaful after in period 1. It will be alpha plus gamma because alpha is a constant. Here, because we are at T0, so this term will go to 0. Gamma Ti1, it will be 1 because she is treated at period 1. And this last term will be 0, so it will be alpha plus gamma. And finally, the outcome of individual I after the program, if she is treated at T equal 1, it will be alpha plus beta plus gamma plus delta because our capital T is 1 because she is treated and she is beneficiary of takaful, and our small t is 1 also because we are talking post the implementation of the program. Okay. So again, now we are discussing in the previous slides, we were talking about someone who does not benefit of takaful, not before 2015 and not after 2015. Now we are talking about someone who is benefiting from takaful after 2015. So the expected outcome of this individual when she was at period t equals 0 before the implementation of takaful, taking into account that we know that in 2015 or after 2015, she benefits from takaful, will equal alpha plus beta multiplied by 1 because the capital T equal 1 because we know she is beneficiary, multiplied by T, but T equals 0 because we are talking on the period before the implementation of the program. So this term will goes to 0. Plus gamma multiplied by T capital I1. We know that this individual is beneficiary, so it will be 1. So alpha plus gamma plus delta multiplied by T, and we know T equals 0 because we know that we are talking about the program, the period before the implementation of the program. So the expected outcome of Russia in 2013, and we know that Russia is beneficiary of takaful in 2018, it will be alpha plus gamma. What would be the outcome of Russia if in 2018, taking into consideration that we know she is benefiting of takaful, it will be simply alpha plus beta multiplied by 1 and multiplied by 1 because T capital is 1, she is beneficiary, and T small is 1 because we are post 2015, plus gamma multiplied by 1 because we know she is beneficiary, plus delta multiplied by 1 because we know we are in the period before post 2015. And of course, in all cases, the expected value of epsilon equals 0 because this is one of the assumptions of the regression that Shahir discussed yesterday. Yes, Hiba, go ahead.
So I think it's the mix-up between the capital T and the small t. Is there a correlation? If capital T is the treatment, so then it's natural that it only occurs at T equals 1.
Yes.
So in all cases, at T equals 0, the capital T should always be 0, but
yes.
Okay.
Yes, but this is the case here. Exactly what you are saying. The outcome of an individual I before the implementation of the program, even if the individual will benefit later, capital T will be 0 because no, sorry. No, sorry, I confused you. The T we have here is TI1. This means that the treatment status in period post the implementation of the program, because exactly of what you are saying, in all cases, the treatment status of the individuals before the implementation of the program is all 0. If I return back to the slide, here in the first variable is the treatment status TI1. TI0 by definition equals 0 because before 2015, no one in Egypt has been selected for takaful because there was no takaful at all. So we are not including in our regression. What we are including in our equation is only the treatment situation after the implementation of the program. For this, I have capital TI1.
Yes.
Is it clear?
Yes, yes.
Okay. Okay. So now if I want to see what is the difference in the expected outcome of Russia between 2013 and 2018, taking into consideration that Russia benefits from takaful in 2018, it will be simply the expected value of yi1 given that ti1 equal 1 minus the expected value of yi0 given ti1 equal 1, which will be, I think someone answered, beta plus delta. Exactly, Musab. It will be this equation minus this equation, it will be beta plus delta. So now we have the difference of the outcome between the individual, of the outcome of the same individual who is not beneficiary at period T1 and period T0, and the difference in outcome between the difference in outcomes of a beneficiary in T1 and T0. So for the treated individuals, we make B minus A, the difference between their outcome after and their outcome before. For the comparison group is D minus C, is the difference between the outcome post 2015 and before 2015, and now to calculate the difference in difference to be able to understand what is the impact of takaful on the consumption of fruit and vegetables, simply we have to do difference in difference. The difference between this first term, B minus A, minus the difference in D minus A, okay? So this difference in difference make us understand what is the impact of any program. So in our case, in the first difference, which is related to the treated, is beta plus gamma, as you said, and the second difference for those who are not benefiting from the treatment is gamma. So simply, if we want to make the difference between SCD1 and SCD0, it will be beta. And this beta, if we go back to our equation, this beta is the interaction, is the coefficient of the interaction term between the treatment dummy variable and the time dummy variable. This means that this is our variable of interest, beta. This beta is the coefficient of the interaction terms, and it shows us the difference in difference, which is the impact of the program we are interested in on the outcome, our variable of interest. So this beta, is the difference in difference estimator that we are interested in. So under the weaker type 1 identification assumption, the effect of the treatment on the treated will be given by this coefficient of the interaction term, which is the beta in our case. Any question, comment? Okay. So all what we did till now is that we were doing the simple regression, not simple regression. We are simply regressing the outcome of interest on the time and the treatment dummies. But we can also include other covariates in our regression that may explain the fact of being treated or not treated. So in this case, we will have the same the constant term. Then we have the three terms of interest: the interaction, the dummy, and the treatment, the time dummy, and the treatment dummy. And we'll have a group of explanatory variables: x, I, t, g. So x is the, for instance, age of individual I at period t, and xg is a variable. So x1 for individual I at period t, x2 for individual I at period t, and for all the others. And again, we can include all the observable variables that I think it can affect our outcome of interest. So for instance, for the example of takaful, if our y variable is the consumption of fruit and vegetables, so maybe we can include the age, the sex, the education, the employment of the head of the household size. All these variables can be included. But again, even if we include the covariates, ATT, or the average treatment of our average treatment on treated of our program, will equal to the coefficient of the indicator of the interaction variable. Okay. And one thing else we can do it if we are interested in studying the effect based on different categories. For instance, if I include education level as an explanatory variable, as a covariate, so I will include a dummy variable equal 1 if the individual, for instance, have a university degree or higher, and 0 if he has lower than this. I can interact this variable of education with my interaction variable t star, t multiply t the treatment multiplied by t the time, and this interaction between the time dummy, the treatment dummy, and the covariate will give me the impact of the treatment on specific group. Okay. Yes, beta measures the effect of the program in the difference in different method, because it shows you, beta shows you, as we see in this previous slide. Okay, is the difference, beta is a difference between the difference in outcome between period 1 and period 2 of the treated individuals, and the difference in outcome between period 1 and period 2 of the non-treated. So it shows you the difference in difference, and this our indicator of interest. So if we wanted to have heterogeneous effects, because this data shows you the average treatment of treated among all individuals, but maybe I wanted to divide it, for instance, if I want to differentiate between the impact on male-headed household and female-headed household. So in this case, I have to interact the treatment dummy variable with the time dummy variable with the sex of the head of the household, and it will give me two different values of beta. Beta for the female-headed I mean, it would be other name, but it would be beta for the female-headed household and beta for the male-headed household. So maybe overall, the takaful increases the food and the fruit and the vegetables consumption of the household who are treated, but this impact is more important among female-headed households compared to male-headed households. Okay, is it clear? Okay. One thing that also I told you that it's not necessary that we calculate the difference in difference only in two periods of time. We can do it in the same period. So if we have cross-section data, we can again run it, but it will be based on groups of individuals. So this group of individuals living in a given village or sheikha or governorate, it depends. But we'll assume that we have one group of individuals who has not been treated at all. So as if we are in period 0, and one group of individuals who have been selected to, for instance, if I assume that I will compare Porsaid and Ismailia, Porsaid, no one was selected for takaful. Ismailia, individuals from Ismailia were selected for takaful. So as if Porsaid is period 0, where no one had been selected for the treatment, and Ismailia will be period 1, where some individuals have been selected for treatment. So we will have targeted and non-targeted villages of microcredit, for instance, and this is the example we will study. And we have in the targeted village, we will have participating and non-participating household. So the non-targeted villages will be as if it's time 0, and the targeted village will be time 1, where we have some participant and some non-participant. So in our equation, the time dummy will be state dummy. Okay. For instance, the origin of takaful, the origin of difference in difference, it was conducted by, I will tell you the name of the by a physician. His name is John Snow. In fact, he wanted to study the cholera epidemic in London, and he differentiated between areas in London based on the quality of water. So according to him, the death rate changed from one area to another area based on the company that is providing water, if this water is clean or not. So the same idea will be studying, we can study the impact based on areas or villages, not in 2 points of time. Okay. So non-targeted villages are not expected to be affected at all, as we're the situation in period 0, where TI0 equals 0 for everyone. So we'll differentiate between participating and non-participating households in such a village. This will be the period 0, and the other and the other one where we have where the village was selected in the beginning. Okay. Another thing that that we can use, in fact, is we can get benefit of the two methods we started till now, the PSM and the difference in difference. So in this case, we will use a difference in difference, but how we will match the participant and non-participant, we'll be doing it based on the PSM. So we'll see in the steps when we'll apply the data. First, we'll run a PSM. We'll match the individuals who are treated with the individuals who are not treated based on their propensity score. and then we can calculate difference in difference based on this matched sample. Or we can use the propensity score as a weight, as we saw yesterday in our analysis, by using it as if it's weighting sample, and run the regression of difference in difference, regressing the outcome of interest on the treatment indicator and on the time indicator, the interaction and the covariates, taking into consideration the weights that we created using the propensity score. So in this case, we make a better matching using the PSM, and also we consider or we exploit the unobservable characteristics that are not changing over time by using the methodology or the difference in difference. Any questions, feedback, comments?
In cross-sectional difference and difference, is it like a two-sample t-test?
In fact, yes, we can do this even over time. I will show you in Stata now. We can do this, or you can consider that village who are not targeted. It can be as time t0, and village who are targeted as t1, and then you can make difference in this village and difference in this village, and then make the difference in difference. But in general, difference in difference, it can be seen as a t-test between two groups or two subgroups, and I will show you. And is supposed to give you the same results. If you assume that there is no difference between the two subgroups, using difference in difference regression method, you have to get the same results. And we'll see now.
Thank you.
Other questions? Okay. So just a quick comment concerning the data and the data we have to use before starting working on with the software itself. That usually if we want to make it over time, we need to have panel data, so different observations that are observed over several points of time, or at least 2 points of time. And I don't know if you are familiar with this or not, but panel data can come in two shapes: long data and wide data. The long data, it looks like this. So you will have, you can see, so first column you have the ID of the individual, and second column is the year, third column is here the sex, and the fourth one is income. So for individual one, we have 3 lines. Each line corresponds to 1 year. So so the first year is 80, 81, and 82. Sex variable is one of the variables that does not change over time, like the place of birth, for instance. So it's supposed to be the same over all the years, and the income change over the years, so we have different values. Individual 2, we have same thing, 3 lines for the 3 years. Each line corresponds to a given income. Okay, so this is the long shape or long data version of the data set. Also, we have wide data, and this wide data you can see. So you can reshape, and we'll see using Stata, we can reshape the long data set this way into wide data. And you can see in wide data, each individual will have only 1 line. And for the income, the variables that change over time, it will be, will have kind of indicator or suffix on the variable. So instead of having here a variable named income, and we know that this income change among individuals and among year, among I and G, now we will have for each individual a line, and this line will be, we'll have 3 variables for the 3 years. If we have 2 years, it will be 3. We have income for 80, income for 81, and income for 82. And in this case, we have, for the variable sex, we have only sex, we will not have a suffix of the number of the year, because it's not supposed to change over years. In fact, it's not what is better. It depends how you would like to make difference in difference. If you want to calculate difference in difference, you have to use the wide form, okay? So I will show you now in Stata, when you use the reshape, usually you will lose some variables. Those cannot change over time. So sometimes to avoid any loss in variables, I will show you how you can reshape it without, reshape it, create variables in this shape without losing bias. Because if you want to calculate the difference in income for individual one between 80 and 82, in this shape, it will be straightforward. You will add a 6-column named income difference equal income 81 minus income 80. But if you use the long data, you cannot really do this. So for difference in difference, you have to use the wide data format. And how to transform it from this to this, we'll show you using Stata. And usually it's through the command reshape, but we'll use another method in the example. I will show it to you now. Okay. Any questions, feedback, comments before starting data? Okay, apologies, I didn't send you the data set. I will send it right now. And if you can give me like just 10 minutes break, and we'll be back at 4:30, I will send you the data sets just to give you the time to download the data and open your set, okay? Let me stop sharing. Hello, everyone. I'm back. Did you receive the data set? Okay, great. So now we'll start working on this. Okay, thank you all for answering. Let me just close this one. Close this one. Okay. So this data set that I sent you, it's part of the, in fact, it's part of 3 surveys or 3 rounds of survey. I think you can see it here. From the Bangladesh household survey for mainly 2 years, 91, 92, and 98, 99. Okay. These data include, so there are the one for 91, the one for 98, and the one for the 2 years together. This data set includes information about households. Some households were followed in 98 based on 91 surveys. We have individual and household characteristics and village level characteristics. What we wanted to do is to study the impact of microcredit programs in Bangladesh on household welfare, and we'll use the total expenditure as an indicator of household welfare in this example. So it's quasi-experimental evaluation. We have 29 thanas, which is kind of sub-districts in Bangladesh in 91. 24 thanas were targeted by the credit programs, and 5 ones were not targeted. Of the targeted household, about 60% were able to participate in the program. And one of the eligibility criteria, in addition to the household, to the individual characteristics, is the ownership of 1/2 acre of land. This was kind of eligibility cutoff. And there were 2 groups, microcredits for men and microcredits for women. So we'll study both to see the impact, if the impact differs by sex or not. So let's start. So here I just simply use the original file I sent to you, where we have the 2 years. And as I told you, I saved it as another one just for being sure that I'm not really destroying the original data set. Let me start by seeing or showing you what are the variables included in our data set. So we have a household identifier. We have the year of observation, 1 for 98 and 0 for 91. So we have the dummy variable for year. We have a village identifier. We have a sub-district identifier, and we have some characteristics of the household: the age, the gender, and the education of the household head. We have the household size, the ownership of land, total assets. We have total per capita expenditure and total food and non-food expenditure differentiated if you want to study both. We have 2 questions that are our questions of interest for the treatment. We have a question or if in the household there is a male microcredit participant, any male participate in the microcredit program in this household. And we have another question for female microcredit participants. So in the same household, we can have male and female participant of the microcredit program. We have the sampling weight, and we have some characteristics of the village, like if the village is accessible by road all over the year or not, a proportion of village land irrigated, and price of some food items like rice, wheat, milk, potato, egg, and edible oil. Okay, so let's start by just examine some variables. We have 826 observations, or 826 households. We have 2 years, 2 points in time, for 98 and for 1991. The duplicate reports allow us to see if any of the how many times it's repeated each observation. It reports the household identifier is replicated how many times or duplicated how many times. So we see that for each household identifier we have two times, and this is because we have data in long shape. If I will show you just a couple of variables to show you the how it looks like. You can see that this is a long shape. You have the household identifier repeated twice. So for each household, we have two lines for the 2 years, 91 and 98, and some variables that does not change over time, like the sex of the head and the household land area is the same for the 2 years. But for instance, for the age, you can see that the head aged between the 2 years by 7 years. So we have it 72 and 79. So this is the long shape, and I will show you how to change it to the wide shape. Okay, so this is the duplicate reports. We have the weights. Now let's see the number of males who are beneficiaries, or number of households that have male beneficiary of the microcredit, and number of female members who are beneficiaries, and if some household have both. So here we have for the line, sorry, for the columns we have if there's a male participant or not. So among the households who have 0 male participant, we have 71 or 72 has also no female participant, has nothing, but 28 has female participant. Okay, and among households who have male participant in the program, 62 has only male, and 38 has female in addition. So in other way, I can say this way. We have 71% of the households has no female participant in any microcredit program, but 29 has female participant, and we have 37% of the households have male and female participant in the same time. So in the same household, we can have both types of beneficiary. Okay, now AW equal weight in the command. So weight in the command is the weight of the survey that is provided with the surveys to be able to how to say, to represent any statistics provided from the household at the population level using this weight. It's provided by the Bureau of Statistics. And when you use the sampling weight in the commands, it allows you to show the statistics and the indicators at the population level. So for instance, let's see this. This I would like to tabulate. I want to see how many households have male participant and how many has no male participant. So we have 79% of the households has no male participant, and 21% has female participant. Has male participant. And you can see here the numbers based on the number of the sample of the household in the sample. You see, when we use the weight, the numbers are inflated to take into consideration because these households are representative at the national level. So we can, if I want to discuss my results or my indicators at the country level, not only using my sample, I would say you see that the numbers are changed, and now I know that I have 88% of the Bangladesh population has no male participant, and 12% has a male participant. So using the weight in the sample, when you add the option of AW equal weight, it uses the asymptotic arithmetic weight and provides you the statistics at the population level. Okay. Now, before the break, I don't remember who suggested that we can do like difference in only the simple mean between two groups or two subgroups. Exactly, this is one of the way to test if there is a difference between in outcome between two subgroups or not. So we can do this, and our indicator of interest that will be interested in is the total expenditure, total per capita expenditure per year in the Taka, Bangladesh, which is around, I mean, at this point, 40 Taka was $1 dollar. So let me, before using the method I am using here, let me show you how to reshape your data from long to wide. So just for simplification, I will keep the household identifier, the year, sex of the head, and the our variable of interest, total expenditure. Okay. So this is a long shaped data set. You can see, as I show you, for each household we have 2 years. Now I want to reshape it into wide format. So I would do reshape wide because it's in long. I will specify the variable of interest, expenditure total. I want to tell Stata which variable is the identifier of the individual and which one is the G. So I in our case is the household identifier, and the G in our case is the year. Something like I think we have to drop sex head as well. Yes. So you notice when I try to reshape it while I have the sex of head that does not change over time, I got an error message. Stata could not reshape it because this variable does not change over years over the G indicator I specified for Stata, so it couldn't really reshape it. But when I drop this variable that is constant over the years, and pay attention that sometimes the variables that we assume are constant over the years, it may change in the data set only for error message. For instance, you will find place of birth Cairo in 90, and in 91 it will be Port Said, for instance. This, I mean, if I was born in Cairo, I will stay born in Cairo till my death. So this would be only an error in data entry, and you have to consider it when you want to I mean, one of the way to clean your data. So when we use the reshape wide, our variable of interest that is changing over time, I and G, I specify the year and the individuals. Stata change me the shape of the data, and if you check how it looks like, so now we have for each in the household, we have only one line, and for this one line we have a variable called x.0, which correspond to the year 91, and x.1, which correspond to the year 98. So instead of having 2 lines per household, we have only 1 line, and we have the variables in horizontal order. Okay, so this is how we want it as well. But I will not use this command to reshape or to provide the data as I mean, to be able to calculate the difference, simply because I don't want to lose the other variables. So I will return back to my data set. Okay. And what I will do is that I will create a new variable. I will call it x.0. I think you can see it. And this variable equals the variable total expenditure if year equals 0. Okay. Of course, it creates missing because it creates missing for the year 1. If I will show you year x dot, you can see that now I have the original variable x tot, which is the per capita total expenditure, and you have the variable I created x dot 0 that equals the same value of the total per capita expenditure in the year 0, but equal dot in the year 1. Okay, so now what I will do is then I will create a new variable. I will call it egen x.91. It equals the maximum of the 2 lines by household. So here I want Stata to create a new variable called 91. For each household identifier, it will compare. So you know that we have 2 lines for each household identifier. So Stata will compare between these 2 lines and will take the maximum value and put it in the variable x.91. I will show you how it will look like. So you see here that I have total expenditure per capita as the original variable. We have x.0, which is equal to the same value of total per capita expenditure at the year 91 and equal missing at the year 98. And then I created new variable. I call it 91, where for each, the value of this variable will be the same for the 2 lines of each household. Okay. Why I'm doing this, I will show you in a minute. It's just a way that I wanted to create total expenditure per capita for 91 and total expenditure per capita for 98 to be able to make the difference later. Maybe it's not the best way to do it. You can find other ways, but I didn't want to use the reshape and lose observation. I can do it, reshape it for all the variables that change over the years, and keep all the variables that invariant over the years in one file, in another file, and merge it together. This is another option, but I just wanted to use different methods. Am I clear, or I'm losing anyone? Okay, so after creating this variable, I will keep if year equal 1. So I will drop the year 0. So when I keep if year equal 1, again, you can see now that I have, for each household, I have 1 line. I have only year 1. I have a total variable called, I have the original variable total expenditure that equals the value of total per capita expenditure in the year 1, which is 91. And I have the variable I created, total expenditure 0 equal missing, because for the year 1, this variable equals missing. And I have another variable called total expenditure 91 equals the value of total per capita expenditure in the year 91. So what I simply have to do is to drop this missing, all missing variable, expenditure total 0, and I will rename total expenditure per capita this 98 to have the 2 years that I'm interested in. So I will go back here and I will rename total per capita expenditure total x.98. I will drop it, and if I want to see the sum, now you see the distribution of the total per capita expenditure in 91. It was the average was around 45 Takan Bangladeshi, and in 98 it increased to 587. And if I wanted to see it, you see that now I have 2 variables, 2 columns. One for the total per capita expenditure in 91, and one for total per capita expenditure in 98. And for each household, I have now only 1 line. Okay. I will create the log. I will work on the natural log of the total per capita expenditure. So I will use the command gen. And then I will create the difference between the log of per capita expenditure in 98 and the log per capita expenditure for 91 for all the household. So for all the household, I can see the difference if the consumption increased or decreased among over this time span. Sorry. And if we would like to see the mean of change, we see that on average, in average, some households see their consumption decreased. Total per capita expenditure decreased. Other households see the total per capita expenditure increased. And on average, there was an increase of around 19% of the total per capita. Okay, the first thing we'll do now is we'll test the difference between the means of recipients and non-recipients of the total per capita expenditure, and this t-test does not take weights into consideration. So it will be it will not using the it will not use the sample weight. if we simply do this, here I'm showing you the descriptive statistics of the total per capita, the length of total per capita expenditure in the difference between 98 and 91 among the recipients and among the non-recipients. And among the male recipients, you can see that the average is around 0.19, while among the recipients is 0.15. Now I want to see if there is a difference between the recipients and the non-recipient over the years by this simple t-test. So from the t-test, we have for each group the descriptive statistics, the number of observations, the mean, standard error, standard deviation, and interval of confidence. And we have over the difference, and you can see from the test, we can conclude that there is a difference in change in the total per capita consumption between male recipient, between household who have male recipient and household who have no male recipient, or there is no significant difference. This is a question for you to just wake you up. So in this table, we have the descriptive statistic of the length of per capita expenditure for households who has a male recipient of the microfinance program, and those who have no male recipient of microfinance program. And we have a t-test. We can conclude from this t-test that there is a significant difference or there is no significant difference. Okay, let's see. Heba and Joad said that there is no significant difference. Indeed, there is no significant difference. We can conclude that if the household has a male recipient or household who has no male recipient, this will not make a change in the, or significant change in the total per capita expenditure over the 7 years between 91 and 98. Another way of testing if there is significant difference or not, we can do, I mean, these are really simple methods just to show you that we have to achieve the same conclusion until we arrive to the difference in difference method. We can simply regress the length of the difference in total per capita expenditure on a dummy variable of the male or not, male recipients or not. The B0 dot option allows us to explain to Stata that this is a categorical variable and when to make zero category for the non-participant. And here you can see from the output that we don't have significant impact of being male, of having a male recipient or not having male recipient on the difference in total per capita expenditure over the years. Okay. All right. Let's see among females. And keep in mind that we said that we can have in the same household male recipients and female recipients. We will do the same thing. And can we conclude that for female as for male, the household who have female participants in the microfinance program, there is no difference in the total in their total per capita expenditure compared to those who have no female participant, or there is a difference? And if so, I want to see if the difference is significant or not significant, and if it's significant, who has higher total per capita expenditure? Question. Wake up, guys, please. I don't understand your comment, Joad. So, does it mean there is significant difference or not? I'm not sure I understand. So, someone said significant. Yeah, Heba is exactly, it's significant. We have significant difference. Exactly. So, if a household have female participant in microfinance program, this will increase their per capita consumption compared to households who have no female participant program. So we can see that this program will affect significantly the per capita consumption of the household if the participant is female, but if the participant is male, it will not be the same thing. And if we run the regression, we can see that it's significant and positive. Okay. Now let's go to the difference in difference method. So keep in mind that we have to estimate the same equation we discussed in our presentation. So we regress our YIT, the outcome of interest, which is in our case the food total per capita, the total per capita expenditure on constant term on treatment dummy, and this treatment dummy equal 1 if we have male participant, 0 if we don't have male participant, and in another case it will be 1 if we have female participant, 0 if we don't have female participant. We'll have time variant, which is 1 if the year is 98, 0 if it's 91, and the interaction between the two variables. So difference in difference or DD or beta in our example will be the coefficient of the interaction. Okay. And to do so, if we notice that here we are regressing YIT, which means total per capita expenditure at period T on the dummy variable, the time dummy variable, and the treatment dummy variable, and the interaction. So we need to go back to the long shape of the data set. So I will use again the same, the original shape. Then I will generate the total per capita expenditure. Okay. Then for male, I will create a dummy variable equal 1 if I have a male participant in year 1. Okay. So this is the thing. And I will create a dummy variable called, so for each household, we'll have only one, this variable DMMFD98 will equal 1 if the household have a recipient, a male recipient in 91, and I will create an interaction dummy between this dummy variable and the year. So again, the DMMFD98 is our TI1 variable. It's the variable that equals 1 if the household have been participating in this treatment, which means that they have male recipients in 98. So this is our capital TI1, and the interaction between this variable and year will give me the interaction variable, which I call DMMFD year. And the variable year is already a dummy variable that equal 1 if the year is 98 and 0 otherwise. Okay, so in this case, I created the 3 dummy variables of interest for the male group. I will do the same thing for female. Okay, and I will run the regression for male. Okay, so in this regression, I regress the log of total per capita expenditure for year T on the dummy variable for year, the dummy variable for being treated or being beneficiary of the program in 98, and the interaction. What can we conclude from this output? For the 3 variables, for the year, for the treatment dummy, and for the interaction. Any volunteer answer?
The year is the only significant variable.
Exactly, the year is the only significant variable. So if we come from between 98 and 91, we can conclude that there was an increase in the total per capita expenditure of the household, and being treated in 98 has no significant impact on total per capita expenditure, and the interaction variable, which is our variable of interest. The beta of the coefficient of this variable shows us the average treatment on treated is not significant. So you can see that when we make a simple t-test comparing between the difference between the two groups, and when we regress the difference on the dummy variable of being beneficiary or not, or when we use the DD method, we have to conclude the same thing. It doesn't make sense that in one case it will make sense, it would be significant difference, in another case it will not make significant difference. Okay, I will send you now through the chat this part of the do file of the construction of the variable, so you can do it directly. Then I would like you to run the same regression I did, but for women, to see if there is a significant impact or not. And then I will ask you to add the 3 variables as covariates: sex of the head, age of head, and education of head. Okay. So these are the commands to be able to create the variable of interest, just not to lose time and to do it directly. Then please run this 2 regression, the same as this one I did for male, but do it for female. Regress to find the average treatment of treated for having female participant in the household, and then run the same regression for women using additional 3 variables, which is the sex of the head, age of the head, and education of the head. I will give you like 10 minutes, and then I would like to hear your conclusion of this, and if you have any questions. So I send you some lines of my do file. If you run it on the data set I sent to you, you will have all the needed variable. What I did now that in this command that I regress the log of total per capita expenditure on the dummy of year, dummy of treatment, and interaction between both. And I found the coefficient of the interactions not significant. This was for the treatment of having male participant in the household that is not benefiting from the microfinance program. I would like you to do the same thing, to run the same regression, the one I'm highlighting here, but for the female program, okay, which is the variable. The variable is DFMFD, okay, and so DFMFD 91 will be for the treatment, and DFMDYR is for the interaction. So I want you to run the same regression for women to see if there is significant impact or not on having a female participant in the household, and then run the same regression, but by adding to this regression the sex of the head, the age of the head, and the education of the head. Please let me know if it's clear or if you want me to repeat again. If you have any question or anything is not clear, please let me know. Musab, you would like to share with us your results? Musab, would you please unmute yourself? Yes. Okay, anyone would like to share their output? Josephine, would you please share your screen? Just to see, maybe when you copy it, there is something wrong. Yes, please share it. Okay. Yes. In fact, when you write, you see this slash star. This is a way to write comment. Sometimes it's for SATA is so close and it cannot understand what is the slash. So it's better to move to remove the comment treatment group, or to put it in another line. Yeah. So you see in your second line in your Second line of gen DMMF DYR, the slash is close to here and a little bit far from interaction, the same for the other ones. And this for sometimes for SATA is not clear. So you have simply to delete it or to put it on in different line. Just check it and please let me know if it works or not. Okay, so let me share my screen and we can discuss, and just let me know if you had the same output or not. If anyone has any problem with the commands, just let me know. Okay, so here I rerun the regression using I regress the total per capita expenditure on the dummy of year, the dummy for being having any female member in the household who is beneficiary from the treatment, and the interaction between both. And here we can see that all variables are significant. So over the years, as was found for the male participant, we have increased and positive increase in the total per capita expenditure between the 2 years. Also, we found that having female participant in the microfinance program decrease the total per capita expenditure. So households who have female per capita expenditure, households who have female participant in the microfinance will have lower per capita expenditure, but our coefficient of interest, which is the DFM FDYR, is positive. So this means that when the difference in difference estimator that measures the average treatment for untreated for the microfinance programs for female shows that any household who has female participant in the microfinance program has positive, significant, higher total per capita expenditure compared to those who have not been participant of the program. So our indicator of interest is significant and positive, showing that we have positive impact on the microfinance. And this shows that the same program may have positive impact for women, but it's not the case for men. For men, there was no significant difference. Then I add other variables in the analysis, in the regression. And as we said, we can include other covariates, other observable variables that can be included or that can be observed and can explain our Y variable, which is the total per capita expenditure in this case. And these variables include sex, age, education of the household head, as we told you. I also include some characteristics of the village, like access to road over the year, price of rice, price of milk, of oil, of wheat. And also I added land size, land ownership, and we included in logarithmic format. And this is what I found, what the results are. So given this result, what would you conclude? These are for men. So I conducted the same regression, sorry, for female, for women. What you can conclude from this? So here we regressed the total per capita expenditure in logarithmic format on dummy variable for year, dummy variable for being treated in 98, interaction between these two dummy variables, sex of head, age of head, education of head, ownership of land, access to road, and price of different components of food or different food items in the household. Would you please let me know what we can conclude from this? Okay, so yes, from the output results, we found that the higher, in fact, this is not a woman's level of education, this is the education of the head. So the higher the education level of the head, the higher the total per capita expenditure would be. So education of the head has positive impact on, significant impact on the total per capita expenditure. What else we can conclude from these results? Thank you, Joad. Other comments, other results that required interpretation?
Land as well is affecting expenditure positively.
Exactly, Razi. So the larger the area of land owned by the household, the larger the per capita expenditure. So these are mainly the two significant variables. We have also price of milk and egg. But what is interesting here, I would like to share it with you or highlight it with you, is the fact that our variable of interest, the difference in difference coefficient that reflects the average treatment of untreated, become not significant. This means that when we take into consideration other covariates who are observed, the effect of the treatment or of having any female participant in the program become not significant. So this means that maybe in this case, the other explanatory variables or the other observed characteristics of the household, this explain more the total per capita expenditure. So again, when we regress the total per capita expenditure on our three dummy variables, the year dummy and the treatment dummy and the interaction, we found that the interaction variable, the coefficient is significant, showing that women, households who have female participant in the microfinance program had higher significant total per capita expenditure compared to households who have no female participant. But when we include other covariates that would explain the total per capita expenditure, we found that this difference in difference indicator become not significant. This means that when we consider the other household and individual characteristics, like the age, the education, the sex of the head, the ownership of land, this explains the total per capita expenditure and makes the interaction dummy not significant. Okay, so the significant change is still positive, but it's not significant. Yes. So the introduction of characteristics has led to change in the coefficient. Of course, we need to be sure that we don't have a problem of multicollinearity that shows that changes the significance of our variable of interest. But another way, so this one to be sure, if there is no problem of multicollinearity, this will show that when you consider other variables that are observed, this may explain or fade the impact of the participant in this program or in this microfinance program. So this I wanted to share just to shed light on this one. Two last things I wanted to highlight today. Again, maybe we want to see the difference in the average value of the characteristics we are including in our analysis, all these variables that I include, between the different groups, the treated and the not treated, okay? I created a variable, a new variable, takes 4 categories based on the treatment situation and the year. So label, so this is, I created using group. So I created these 2 variables. The first variable named is group underscore M. This variable have 4 categories. Those who are in the control group in 91, those who are in the control group in 98, those who are treated in 91, and here the treatment is having any male participant in the program in the household, and T98 having any male participant in the household, okay, based on the data. And same thing for female. And then I will check the difference in the average of the characteristics I'm including between these different programs. So this tab form allow us to create an Excel file showing the average between the different categories and also testing the significance. Okay. Let me see. Okay, let me try this one. I will open the file, the Excel file. Okay. So you can see this command produce this Excel file. No, if you can see it. So here I am doing only for participant and non-participant. So 0 means that households have no male participant in the program. 1 means that household has male participant in the program. And I have the different variables and the significance level of difference. So you can see from this that there is a difference in land ownership between the participant and non-participant. The participant in the program, those who have male beneficiaries from the microfinance, have lower land ownership, and this is expected because this is one of the criteria to be able to benefit of the microfinance program. For the gender, most of the all the households who have male beneficiary from the microfinance program have male head household. Same things for the age of head for households who have male participant in the program is they are younger compared to the others. And for all the other variables, there is no significant difference. There is significant difference in the price of edible oil in the village between those who live in the house, for the household who have beneficiary and the household who have no beneficiary. Of course, here it's not important to have significant difference or not significant difference because we are not matching them both on these characteristics. But at least we need to understand if there is a difference between the participant and non-participant in this program. Okay, any questions, feedback, comments? Okay, now let me move to the final thing I want to show you today is how we can match or how we can use both the PSM and the difference in difference. So the idea is that we can refine and match the individuals based on PSM score to match treated and the control groups. Then I can apply difference in difference on the matched sample and remove any heterogeneity that would exist in the data set before the analysis, okay? So what we will do, we will use again the same regression. Here I'm just constructing some variables of interest. Okay. So these variables are already created. We will keep only if year equal 0. Okay. So this is to match first based on year 0 to see the treated and the non-treated. Then I will merge it with the other data set, and I will do the difference in difference. So first step, we will match the observations based on the propensity score in the year 0. Okay. Let's go this way. Okay. Here we are using, in this example, I use P-score. I use all the characteristics I included in my regression: sex of head, age of head, education of head, land ownership, access to road, prices of different products in the village. Okay. And here we have the probit regression. We can see that age of heads affects the likelihood of being participant in the program, of having male participant in the program. Also the land ownership. These are the main two significant variables. And here for the P-score command, it shows us the region of common support. Between these two values, the individuals are matched. So we are matching individuals who have P-score between these two values. And we have description of the PSM. And here, in fact, P-score use blocks to be able to match the individuals based on the P-score. Okay, after running this command and matching the individuals based on the P-score, P-score command created a variable equal 1 if the individual is matched 0 otherwise, like the same thing in PS match 2, but here the variable is named is comsup. Okay, so I will keep households who are matched by keeping household who have concept equal 1, which means that's the household that we found their match. Okay, then I will keep only two variables, the identifier of the household and the score of the household. Okay, then I will merge it again with the original variable, with the original data set using the household identifier. Of course, here I have some households who are matched and other not. I will keep only the matched ones. Okay, and then I will start running the regression. So again, what I did that I used my original data set. I only kept household who have I only kept year 0 to match between the household based on their P-score using the year 0 before the implementation of the program. Then I will keep only the matched household, the household that I am sure that I found counterpart in the non-beneficiary households, and match them and then merge them again with the original data set. This I will create my variables of interest again because I lost them. And here what I will do is I will use the scores of the match of the individuals of the households to create the inverse probability of weight. If you remember, we talked about yesterday, to be able to use the sample, the propensity score with the sample weight in my regression. Okay, so using the formula of yesterday for creating the inverse probability, so I will give more weight for households who have less likelihood of being selected, and I will use lower weights for households who have higher likelihood of being selected to be able to create, given different weights to the different household. And after creating this weight, I will run the regression by using the T weight I created based on the P-score and on the sampling weight in my regression. And here, so from our results, what can we conclude? Same conclusion as what we found from the sample t-statistic difference, from the regression with only the 3 variables of interest, the dummy time, the treatment time, and the interaction between both, and also the interaction between them. And when we include the variable axis in all types of methods we use, we conclude that households who have male participants in the microfinance program have no significant difference in their total per capita expenditure compared to households who have male participant programs. But the advantage of this last method that I am using both methods, the advantage of both methods that I first match the household using propensity score in year 0, then I will work only on this matched household to make the difference and see if the program is significant or not, and we found the same conclusion. Is it clear? Any comment? Anything is not clear? Okay, I will do the same thing for women. I will do the same steps. I will only use the matched method. I will match them based on the year 0. I will use the matching or propensity score to create the weights, and I will run the regression using the inverse weight. Okay. Right. Okay. Here I merge with the original file. I keep only those who are who have score, who have been matched, and I created the weight and then run the regression. So because some variables were already created. Okay. So here they told me that weight is already defined. I defined it for male. Now I have to do it for female. And I run the okay. Sorry, there is something wrong here. So let us start again. This is just the problem of the file I am using, which path I am specifying. Okay, so I create the variables, I keep here 0. Here I match, but here pay attention. Here I am considering the program is the fact of having female participant in the household, not male participant in the household. Okay, we'll keep those who are matched, and then we'll merge with the other data file. Okay. Okay, and here you can see that same thing. The year have significant impact on total per capita expenditure, but the difference estimators that we are interested in is not significant. And this confirms what we found. So when we started with the t-tests between the difference in two samples, those who are beneficiary from the program who have female participant and those who have not female participant, we found that household with female participant have higher per capita expenditure. When we run our regression with the time dummy and with the treatment dummy and the interaction variable, we found that also having female participant in the household have significant impact on positive impact on the total per capita expenditure. However, when we start including other variables, other demographic variables of the household, we found that this difference is not significant anymore. And here it's confirmed when we match the household based on observed characteristic, and then we run the difference in difference method, we found that it's not significant. This means that when we consider the other observed characteristics in this case, the significance of the program is not anymore. So this is advantageous to use both methods because it allows you to have better matching of the households and be able to run or take the advantage of the two methodology or the two methods. Any comment, questions, something not clear? Anyone is still awake? Okay. Yes, thank you, Josephine, for answering. Thank you, guys. Okay, thank you all. So that's great. If you don't have any questions, I will stop here. Again, as we said, we'll share with you all the do files and the presentation. If you have any questions later, something not clear in the do file, you tried another command and you found different results, please let us know. I will stop here, and Shahir, tomorrow we'll continue with you. The third way of solution is the panel data methods. Any last comment before ending the session? Thank you all. Yes, we will have the do files, Fatma. I will send you all the do files. I mean, Shahir and myself will send you no, not today, tomorrow, after we finish everything. We'll send you everything, the presentations, the do file, files, and a couple of papers that may be of interest for you to read it. Okay, if you don't have any other questions or feedback, thank you for being with me this session. And have a good evening, and see you tomorrow, inshallah.